Hello everyone, I am Varsha BS. Today, let's learn about an edge-triggered D flip-flop. Before directly jumping into the topic, let's have a short introduction about what a D flip-flop is. D flip-flop, also called as data flip-flop or delay flip-flop, is a flip-flop having two inputs, one data input and a clock pulse, and two outputs, Q and Q bar. Q bar is nothing but the complement of output Q. I just mentioned that the flip-flop is also called as delay flip-flop. It is because when the input data is given, it is transmitted to the output after one clock pulse delay. Here's the circuit diagram of a D flip-flop. Basically, a D flip-flop is a modified form of a clocked RS flip-flop by fixing an inverter right over here. You can fix the inverter here also. That's not a problem. And this is the logic diagram of the flip-flop. Here's the truth table of D flip-flop. The flip-flop is active only when the clock is at high or 1. When the clock pulse is at low or 0, the input data is not received by the flip-flop, hence mentioned as don't care. But the output Q retains its previous state. When clock pulse is at high, the data input is reflected in Q. That means when the clock pulse is at 1, data is at 0, output Q is 0. Similarly, when the clock pulse is at 1 and data input is 1, the output is also 1. There are two types of D flip-flop, level triggered and edge triggered. The normal D flip-flop is called a level triggered flip-flop because whether the flip-flop is active or not is determined by the logic level of the clock pulse. While the clock is at 1, whichever the logic state D is at will appear at output Q. Look at this timing diagram. Here clock is at 1, data is at 0, hence output that is Q is at 0. Here clock is at 1, data is at 1, hence Q is at 1. Here clock is at 0, but Q is at 1. Why? Because since clock is at 0, the D flip-flop does not take any input. Hence, the Q retains its previous state, that is 1. There is a problem with level-triggered D flip-flop. If there are any changes in the data during period when clock is at high, the logic state at Q also changes with data and only remembers the last input state that occurred during that particular clock pulse. This effect is called ripple through. This allows the flip-flop to be used as a data switch, but this may not be desirable in many circuits. This can be better understood from a timing diagram. Here, when clock is at 1, data is at 0, hence Q is at 0. Next, when clock is at 0, Q retains its previous state, that is 0. When clock is at 1, data is at 1, hence Q is at 1. Next, when clock is at 0, the Q retains its previous state, that is 1. Now, here, when clock is at 1, the data is transitioned from 1 to 0. The same is reflected in the output. And next, when clock is at 0, the Q has to retain its previous state. Now, the flip-flop remembers its previous state as 0 only, not the transition. Hence, the Q retains its previous state as 0. Next, when clock is at 1, data is at 1, so Q is at 1. When clock is at 1, during this period, the data is transitioned from 0 to 1. The same thing is reflected in the output. Next, when clock is at 0, the Q has to retain its previous state. Now the flip-flop remembers its previous state as 1 only, not the transition from 0 to 1. Hence, the Q retains its previous state as 1. The next type of D flip-flop is the edge-triggered D flip-flop. It is a data flip-flop in which the output changes only with the edge of the clock pulse. In other words, the output changes with the transition of the clock pulse either from 0 to 1 or vice versa. The main advantage of edge triggering in D flip-flop is that ripple-through condition can be prevented largely. The difference between level and edge triggering flip-flops is that in level triggering, the active state of the flip-flop is determined by the logic state of the clock pulse, that is, whether it is 1 or not. But in edge triggering, the active state of the flip-flop is determined by the transition of the clock pulse, that is from 0 to 1 or 1 to 0. There are two types of edge trigger D flip-flop. Positive edge trigger D flip-flop, negative edge trigger D flip-flop. In positive edge trigger D flip-flop, the flip-flop is active only at the positive edge, that is the transition of the clock pulse from 0 to 1. In negative edge trigger D flip-flop, the flip-flop is active only at the negative edge, that is the transition of the clock pulse from 1 to 0. Let us learn about it in detail in further slides. Positive edge trigger D flip-flop, usually called as rising edge trigger D flip-flop. It is called so because the output changes on the positive going edge, that is rising edge of the clock pulse. Let's understand it better from a timing diagram. Here, the clock pulse is transitioning from 0 to 1, which satisfies the definition of rising edge. During this rising edge of the clock pulse, the data is at 0, hence Q is at 0. Here, the logic state of the clock pulse or the transition from 1 to 0 of the clock pulse does not determine or is not considered for the activation of the flip-flop. In the next rising edge of the clock pulse, the data is at 0, hence Q is at 0. In the next rising edge of the clock pulse, data is at 1, hence the output Q is at 1. On a whole, the outputs respond to the input data only when enable signal, nothing but the clock pulse, transitions from low to high. This is a logic diagram to show that it is a rising edge trigger D flip-flop. To depict that, we have an arrow in the clock pin. Negative edge trigger D flip-flop, also called as falling edge trigger D flip-flop, is a type of D flip-flop in which output changes with negative going edge, that is falling edge of the clock pulse. Let us understand it better with a timing diagram. Here, the rising edge of the clock pulse, that is the transition from 0 to 1 or the logical state 1 of the clock pulse, does not determine the activation state of the flip-flop. Rather, the transition from 1 to 0 does. You may observe that when the clock pulse is at 0 or at the rising edge or at the logical state of 1, the output does not change. Rather than that, the subsequent falling edge of the clock pulse determines the output. In the first falling edge of the clock pulse, data is at 1, hence the output Q is at 1. In the next falling edge, data is at 0, hence the output Q is also at 0. In a whole, outputs respond to the input, that is data, only when enable signal, nothing but the clock pulse, transitions from high to low. This is a logic diagram of falling edge triggered D flip-flop. To show that it is a falling edge triggered, a bubble before the arrow is put in the clock pin. Let's see what we have learned in this video. We have learned what a D flip-flop is, its logic diagram and truth table, types of D flip-flop, that is level triggered and edge triggered with their logic diagrams, types of edge triggered D flip-flop, that is rising edge triggered and falling edge triggered with their respective logic diagrams, and timing diagrams. I hope the content in this video is helpful for you all. Thank you.